Okay, today we are going to learn about RHS congruence rule proof. I mean, RHS congruence rule is what and how to prove that. So this is what we are going to learn it here. See here, first I will tell you the statement and then I will explain in what way, what is the roadmap to prove this RHS congruence rule. So here I am taking two triangles ABC and PQR, and if you observe here, ABC is a right angle triangle at B and PQR is also a right angle triangle. And if you observe another thing here, AC, what is AC in ABC triangle? AC is a side which is opposite to 90 degrees. Side which is opposite to 90 degrees. 90 degrees is the bigger side, higher side. So therefore this higher side, opposite side is hypotenuse. So AC and in triangle PQR, PR, these two are hypotenuses of their respective triangles. Okay, PR is a hypotenuse of PQR triangle because this is also opposite to Q. Opposite to Q means opposite to 90 degrees. So this is hypotenuse. So we are constructing, I mean, these are the two triangles with same hypotenuse. Two right angles, their hypotenuse are equal with one side equal. Okay, BC side and QR side equal. Then automatically these two triangles are going to be congruent. So this is what we need to prove. Okay, what is the statement? Two right angle triangles are said to be congruent. Two right angle triangles are said to be congruent if the hypotenuse and one side of the triangles are equal to, okay, hypotenuse and one side of one triangle is equals to hypotenuse and one side of other triangle. Once again, these two right angle triangles are said to be congruent when the hypotenuse and side of one triangle is equals to hypotenuse and one side of other triangle. Then automatically these two triangles are going to be congruent. So first I will write the statement, then I will explain the proof. Okay, so I am just writing the statement here. Two right angle triangles, I'm sorry, two right angle triangles are congruent. These two triangles are right angle triangles and they will be congruent when the hypotenuse and one side, hypotenuse and one side of one triangle, hypotenuse and one side of one triangle is equals to hypotenuse and one side of other triangle. Hypotenuse and one side. I mean, what I mean to say is, for example, if AC length is x centimeters, PR length is x centimeter, their hypotenuse are equal, these two are right angles. Next, if BC is y centimeter and QR is y centimeter, then automatically these two triangles are going to be congruent. That means what? Their corresponding angles are going to be equal. Angle A is equal to angle P, angle B and angle Q are already equal. Angle C and angle R are also going to be equal. Not just that, the corresponding sides AB and PQ are also going to be equal. So this is what is going to happen once they are congruent. So now we need to prove it. So what is the way to prove it? See, to prove this, we are going to use the help of SAS axiom. Side, angle, side. It is an axiom. This axiom we are going to, we are going to take the help of SAS axiom to prove this. But how can we prove it? See, here this side and this side is okay, and these two sides also okay. But if I prove angle C is equal to angle R, then that's where my job is going to be done. So if I prove, what is our ultimate objective? We need to prove angle C is equal to angle R. Why? Because these two sides are going to be equal, and these two sides are already equal given in the question, given in the statement. Now once if I prove angle C is equal to angle R, then by SAS, we can prove these two triangles are congruent. So our ultimate target is to prove angle C is equal to angle R. But what we can prove? How can you prove that? Is it possible to do it directly with the two triangles? Okay, it is not going to be possible. So what we are going to do is, okay, so we are going to take the help of another triangle. To prove this, I am going to take another triangle. Okay, so first, to prove any theorem, we need a procedure. First we need to write the given things, and next we need to write the required to prove, and third we need to write construction. If it is required, we need a construction, and later we need to prove the proof. So I am going to remove this statement. I am going to write all those points. See, I am just writing x centimeter, y centimeter only to get a clarity, because if I just write A, B, B, C, C, A, P, Q, P, R, R, P, it creates a lot of confusion, and spelling also, I mean pronouncing such lengths will be little difficult, because A, B, A, C, this creates a little confusion. Only to avoid that confusion, I am taking this x centimeter, y centimeter, because algebra makes our job easy. So first, let me write the given. So what is given? First, angle B, okay, sorry, triangle A, B, C, comma, triangle P, Q, R, right triangles, right angle triangles, right angle triangles. Okay, next, what else is given? Hypotenuse are equal. Okay, such that right angle triangles, such that angle B is equals to angle Q is equals to 90 degrees. This is one statement. Next, their hypotenuse are equal. AC is equals to PR. Next, BC is equals to QR. So this is the given information. Now what we need to prove? What we need to prove? What is required to prove? We need to prove triangle ABC is congruent to triangle PQR. This is what we need to prove. Now we need an extra construction, because with these two triangles it's not going to be possible. So therefore I am constructing an extra triangle. So what I am going to construct is, I am going to extend this PQ. I am going to extend this PQ up to W. Okay, I am extending PQ up to W such that QW length is equals to AB length. For example, I have not taken the AB length, but let us assume that AB length is some Z centimeter. So I need to extend QW in such a way that QW is equals to Z centimeter, or QW is equals to AB length. So extend this. Next, you join this R and W. So this is what? This is an extra triangle that we need to construct here. So what are we going to construct? We are going to construct, okay, extend QW such that QW is equals to AB. So this is the new construction. We have done it. Now see, this is actually a right angle triangle. I mean, this is a straight line, and this is making 90 degrees. When you extend it, it is going to make a line. So therefore, this is also going to be a 90 degrees. Here, this is going to be 90 degrees. Now, what is the length of QW? QW is going to be how much? That is going to be Z centimeter. See, I am just giving, because QW and AB. Now, these two sides are equal. These angles are equal, and these two sides are equal. So okay, I can say these two triangles are congruent. See, I'll tell you how to explain the proof. First, I will prove these two triangles congruent, and next I will prove this angle C and angle R are equal. So first, what we need to prove? We need to prove these two triangles are congruent. How? It's very simple. AB is equal to QW, because by construction we constructed QW in such a way that QW is equals to AB. Next, angle B is equal to angle Q, because angle B and angle Q are 90 degrees, because when we are extending PQ, angle PQR is already 90 degrees. We are extending a straight line, therefore here we are going to get a 90 degrees. So these two angles are equal. Next, BC is equals to QR. So therefore this side and this side is also equal. By side angle side. Okay, side angle side. By SES, these two triangles are congruent. So I am going to write the proof here. So which two triangles I am taking? Triangle ABC, comma triangle WQR. This is the new triangle I am going to take. So QWR. So in that what? In that AB is equals to QW. AB is equals to QW. Angle B is equals to angle Q is equals to 90 degrees. Next BC is equals to QR. So by side angle side, I already told you we are going to take the help of SCERT axiom and will prove this. So by SCERT we can say these two triangles are congruent. By SCERT we can say triangle ABC is congruent to triangle, right? What is the corresponding side of B? We already know that it is Q. So therefore B corresponds to Q. What is the corresponding of, okay, right. Now which two sides are equal? BC and QR sides are equal. So BC and QR sides are equal. Therefore the remaining vertex is P. The remaining vertex of BC is A. Therefore they are going to be equal. That means here Q and this is, BC corresponding is, okay, so A corresponding is P. You got my point? BC and QR are equal. So therefore BC remaining vertex is A, QR remaining vertex is P. They are also going to be corresponding. So A corresponding is P. So this is P, triangle PQ. And what is the remaining? I'm so sorry. Here triangle ABC and triangle QWR. Okay. So which two sides are equal? BC side, BC is A, now QR is equal. Remaining side is what? W. So therefore A corresponding is, I'm so sorry. Okay, please understand once again. BC and QR are equal. Actually we are taking this triangle. BC and QR are equal. BC remaining vertex is A, QR remaining vertex is W. So therefore A and W are corresponding. So therefore triangle A corresponding is what? W. A corresponding is W and B corresponding, just now we have seen angle B, angle Q, they are 90 degrees. So therefore this is Q. So next remaining vertex is QR. So triangle ABC is congruent to triangle WQR. So we proved it. Now what did we get from this? So once these two triangles are congruent, what we can say? We can say that AC corresponding is what? WR. They are also going to be equal. So therefore this length will become what? X centimeter. Next, what is the other thing is going to be equal? Angle A corresponding is what? Angle W. They are also going to be equal. For example, let us take this angle is something called A. So therefore this angle is also going to be A. Just for your understanding I am writing. Now what is the corresponding of C? C corresponding is R. They are also going to be equal. Let's take this angle is some B degrees. This is A degrees. So this angle is also going to be B degrees. Okay. Now see. Okay. Now this is A. This is B. Can I write? This is 90. This is A. Therefore, can I write this is 90 minus A? Will it become 90 minus A or not? Okay. And next, if this is 90, this is A. Therefore, this is also going to be 90 minus A. Or else you can write B also, not a problem. Okay. We will see. 1 second. Okay. So no problem. This is done. Now look at this bigger triangle. Triangle PRW. Such a big triangle. Okay. So in these two triangles, these two sides are equal, x centimeter and x centimeter. How? Because AC is equal to WR. AC corresponding side is WR. But we already know that AC and PR are also equal. That is given in the question. Okay. From these two, what we can say is this PRW is an isosceles triangle. In isosceles triangle, these two sides are equal and their opposite angles also going to be equal. If this is A, then this is also going to be A. This is A means that is also A. So therefore, what sum of the angles in a triangle is how much? 180. So therefore, can you, I just wanted to use this. Okay, I would like to write this one, angle P plus angle PQR plus angle PRQ is equals to 180 degrees. Now angle P is equals to A, angle PQR is 90 degrees plus angle PRQ is going to be, angle PRQ is equals to 180 degrees. Now angle PRQ is equals to, okay, 180 if you transfer to this side it will become 180 minus 90, that is 90 degrees. A if you transfer to this side it will become 90 minus A. Actually here I need not to take this one. Here this is 90 degrees, this is A. Therefore A plus 90 plus this angle is equal to 180. A plus angle B. A plus angle B plus angle C is equal to 180 degrees. Therefore angle C is equals to, this is 90 degrees. When you transfer to this side 180 minus 90, that is going to be 90 minus A. So here angle C is going to be 90 minus A. Angle C is going to be 90 minus A. 90 degrees minus A. So this is also going to be 90 minus A, because this is 90, this is A. So remaining side will be in a right angle triangle. If one angle is x, then the other angle will be, the remaining angle will be 90 minus x. If this is 90, this is A. Therefore this is going to be 90 minus A. And we already proved that angle C and angle R are corresponding and they are going to be equal. So if this is 90 minus A, this is also 90 minus A. Now what we have done, just now we proved angle PRQ is equals to 90 minus A. Angle PRQ is equal to 90 minus A. That means this angle is also going to be 90 minus A. 90 minus A. Now if you observe these two triangles, triangle PRQ and triangle WQR. Okay, even that is also not required. Here look at these two triangles. Actually what we need to prove? We need to prove angle C is equal to angle R. That is already happened. I told you in starting our ultimate target, if I prove angle C is equals to angle R, then your job is already done. So we have done already. See 90 minus A, this is also 90 minus A. How can you say these two triangles are congruent? See, these two sides are equal, x and x. These two sides are equal and these two angles are equal. Side, angle, side. By SAS, these two triangles are congruent. So therefore, directly I can write it as what? Triangle ABC is congruent to triangle. Okay, A corresponding is what? P. B corresponding is Q. C corresponding is R. So triangle ABC is congruent to triangle PQR. This is what we need to prove it. We have proved it. So very simple. I just wanted to explain the whole idea once again. So first we'll take up the two right angle triangles with the hypotenuse and one side equal. And then we cannot prove these two triangles directly congruent. So we are taking an extra triangle. So we are constructing an extra triangle in such a way that we are extending the PQ up to W such that QW is equals to AB. And then we will join this R and W. We are getting a new triangle WQR. So first I would like to prove these two triangles congruent. That will be very easy because these two sides are equal and this is 90 degrees and these two sides are equal. So automatically by side, angle, side, these two triangles are going to be congruent. Triangle ABC is congruent to triangle WQR, which I have done in this first. That is my first target. Actually our intention is what? If I see, we already know that these two sides are equal. In this triangle ABC and PQR, these two sides are equal. If I prove these two angles equal, then my job is done. By SAS axiom, I can prove these two triangles congruent. So my objective is I wanted to make this angle R equal. Angle R equal to angle C. So how I have done? First I proved these two triangles congruent. Now, so once these two triangles are congruent, okay, A corresponding is W. Triangle ABC is congruent to WQR. So A corresponding is W. If angle A is A, then angle W is also A. And this is 90, this is A, then automatically the remaining angle will be 90 minus A. I explained the process here. So if this is 90, this is A, therefore this is also going to be 90 minus A. That is done. Now look at these two triangles. See, now what, how, see, now what we have to do? So look at this triangle, bigger triangle, PRW triangle. In PRW triangle, these two sides are equal. It's an isosceles triangle. In isosceles triangle, these two sides are equal. Then automatically their opposite angles are also going to be equal. Equal side opposite angles are equal. So therefore, if this is A, then automatically this is also going to be A. Now this is 90, this is A, therefore this could be 90 minus A. So now these two angles became equal. So once these two angles became equal, these two sides included angle by ACS, these two triangles are congruent. That's the idea of the proof. I hope you understood.